Hello, today we're looking at missing angles. Now, already we know that a straight line is 180 degrees. Therefore, if we take any straight line and if we know part of that straight line, part of the turn on that straight line, for example, if we know that that is 42 degrees, it means that we can calculate this part here, the missing angle. Let's call this angle A. So we already know that a full turn is 180 degrees. We know that this part here is 42 degrees. Therefore, if we find out how much is missing, i.e. 180 take away 42, we can calculate what A is. £138 degrees. So to recap, we already know that a straight line is 180 degrees. If we know what part of that angle is, what part of that turn is, if we take this away from the 180, we can find out the remaining angle, the missing angle. It's there. Have a go at these two questions. Pause the video and then check back with your answer. Again, straight line. I am telling you that that angle there is 117 degrees. I am telling you this angle here is 95 degrees. I want you to find angle B and angle C. Pause the video, then check back to check your answer. So again, we know that we have a straight line here, so it's 180 degrees. We're going to take away 117, and then that way we will find angle B. £63 degrees. Same principle here. Great, and my pen is running out. Let's see if I can finish this question. Just. It is also worth noting that with all of these questions, we are calculating. They will not be drawn to scale. And when we've got this information, we are just sketching it. I haven't measured this angle here. I haven't measured any of the angles here. I'm using these as a sketch and we are calculating, and it's these calculations which are the important part. Now, as we already know, a straight line is 180 degrees. Now, if we take an angle, as we've just seen, if we know either one of those two angles, it means that we can find this angle here by subtracting it from 180. Likewise, if we take this angle, this line here, and extend it, we end up with a pair of vertically opposite angles. By that, we mean if we know this angle here, we know that taking this away from 180 will give us this angle here. Therefore, because this line here is also 180 degrees, therefore taking away the blue angle from 180 will give us this angle. And to complete it, that angle there, give us that angle there. So this diagram with the vertically opposite angles being equal is the key, and that is the key phrase. Now this key phrase, vertically opposite angles, is important because you must be able to quote it and write it to show your angle reasoning. So without any calculations, we can clearly see that these two angles are the same and these two angles are the same. How would this work in a question? You could be given any pair of angles where you can clearly see you have two straight lines intersecting. Therefore, if you are told that this angle here is 67 degrees, we know immediately that this angle here and this angle here are the same. Now, as always, you will not gain any more marks for colour coding. However, if it makes your understanding of the topic clearer, colour code. So if that is 67 degrees, that is also 67 degrees because vertically opposite angles are equal. Therefore, again, remembering what we already know, that is 180. So if we take 67 away, it means that we find that angle there, 113 degrees. And again, to complete it, because we know that vertically opposite angles are equal without doing any calculation, we know that that is also 113 degrees, and we can just complete the colour coding. That means that we can see what's going on far clearer. As usual, I'm going to draw out another two questions for you. This angle here is 31 degrees. I want you to find angle. Hold on, where am I up to? Make sure I'm using the correct letters. C, lovely. To find angle D, find angle E. Sorry, find angle E and find angle F. Same principle here. I am telling you that this angle here is 109 degrees. So therefore, find angle G, find angle H, and find angle J. As always, pause the video and then check back to see what your answers are. Before I go any further, I'm going to colour code. As I've said before, it does not get me any extra marks. All it does, it means I can see what's going on clearer. So I'm going to say if that angle there must be the same as that angle there, and therefore this angle here, whoops, the pen's not working. Let's try another one. There you go. This angle here must therefore be the same as this angle here. So without doing any work, I've colour coded it so I can clearly see what's going on. So if that is 31, D is vertically opposite angle, therefore this must also be 31 degrees. I know this is a straight line, so if I take the 180, take away 31 degrees, therefore that must be 149 degrees. Following this, again, those two angles are vertically opposite. So this one must also be 149. Oop, I put 144, 149 degrees. Likewise, when answering questions like this, if you can see a way in, do it. But if you're not sure, it's often best to follow the letters in the alphabet. So immediately I went for D because it's the easiest one with no calculation. E, simple calculation going back to what I originally knew. Later on it will have knock on, knock on, knock on, knock on. But for now, always refer back to something that you know from the question. E, calculation, and F. Same principle again. Let's start off with just pure colour coding. That angle there is the same as that angle there. Therefore, this angle here must be, because they're vertically opposite, the same as that angle there. No calculations, but already it makes it easier to work out. Vertically opposite angles are equal, so if that's 109, that must also be 109. We know that is a straight line. So if we take the 180, subtract away 109, this must be 71 degrees, and again we already know these are vertically opposite. Therefore that one must also be 71 degrees.